Hello, I'm Huagua. I would like to introduce our work, Sedeve-Kit, a specification-driven development framework for building distributed systems. Developing a distributed system is challenging. The hardest part is the combination explosion of program states, making it nearly impossible for the human mind to envision and test all possible states perfectly. Formal verification and specification are valuable for ensuring the mathematical correctness of system design. However, formal methods primarily verify the design rather than the final implementation. It is unrealistic to specify all the details of a system. This raises the question, how can formal methods be used on a system more than a toy? How do we bridge this gap between design and implementation? Since formal methods ensure the correctness of the design, we can implement the system guided by the specifications and verify it using the specifications model state space to ensure the system is a refinement of the specification. Let's use a video analogy. System implementation is like high-definition animation, and the specifications are like keyframes. Our framework helps developers verify these keyframes. Based on this idea, we developed the Specification-Driven Development Toolkit framework, which can help to conduct specification-driven development. This figure shows the components of the kit. TraceGen is a tool used to generate trace sets. The deterministic player controls running actions in the trace order. Ascender SCERD and SNet libraries are used to build network channels. The workflow begins with the design of a system at an abstract level. We run a model checker on this specification, guaranteeing correctness and dumping the model states. Then, we use the TraceGen tool to generate a trace set. We write the code following the specifications guidance. Finally, by running deterministic testing, we validate the system using the player and the trace. We repeat this procedure and validate the system continuously. I will use the RAF consensus protocol as an example to explain how to apply the kit. We develop sculpt RAF projects. Here is the repo page. Before we begin, let's prepare the prerequisites. First, we must download and install the TLA Plus toolbox and the kit. After installing the TLA Plus toolbox, some configuration is needed. Download Sedeve modules, where we have rewritten several TLC operators. Open the TLA Plus toolbox and specify the paths for Sedeve modules and the SQLite JDBC jar. Now, the environment is ready. We then can start developing the specification. The specification defines some constants and actions, as well as the initial and next states, and specifies the temporal formula spec. We abstract the system using the concept of I/O automata, where an ID identifies each node in the system. We also specify some invariants to check if they are violated during TLC model checking. Then, we perform model checking. After filling in the model parameters, we click Run TLC on the model. After a while, the model checking is complete. The model's actions are saved to an SQLite database file. Using our TraceGen tool, we generate a trace set from this file. Now, we strictly follow the specifications when developing. We execute deterministic testing using the trace set and player to verify our implementation. This test validates our implementation. Suppose our code implementation does not adhere to the specification. For example, if there is a bug where the last log index referenced the wrong index when computing the commit index. During the testing, the program will report an assertion error indicating that the system behavior does not match the trace. By performing deterministic testing, our program can consistently reproduce this bug. We can also explore the corresponding trace to observe the system's internal behavior. Another example is a bug causing the system to miss vote request messages from some nodes, which may prevent the system from meeting liveness and electing a leader. During deterministic testing, the program will notify the developer of this inconsistency with a timeout error. By examining the error message, we can see that a vote request message was expected but not sent, quickly pinpointing the defect. Our repository contains more information. All our frameworks, tools, and examples are open source. Our examples include a Docker image for easy learning and using the kit. Thank you for listening.